Okay, thank you very much. Hello guys, my name is Khalifa, and together with my colleagues, we are presenting for group number 6. Our project, as shown in the title, is about accuracy and precision with projectiles. So the objective of this experiment is to observe and record the effects of different heights and objects on the accuracy of the projectile upon landing on a target. Precision and accuracy will be based on the distance the objects will hit from the center of the archery type target. For the response variable, it's going to be the distance from the center of the target, and during the trial it should be observed with human eyes as well as being filmed with a camera. And then after the trial, data will be collected and verified through the film tape. And finally, the target will be a circular design similar to those used in archery. Some factors affecting the experiment. First, we have height, whether it's level 2, 3, or 4. And then what are we going to drop, whether it's the ping pong ball, the quarter, or the empty bottle. Then of course we have people participating in the experiment. For us it's DT, Darius, and David. And then the total number of trials in the experiment is equal to 270 trials.
So this table basically describes our data collection process. Each participant drops one object from each level, so that there are 3 levels for height and 3 for the object and 3 participants. So the effect we're looking at is the deviation of the landing spot from the target center. So we mainly looked at the height, the object, and the person. Although the wind, object spin, and surface type could affect it, we tried to minimize the wind effect by conducting the experiment in an enclosed area in a residential hall at ASU. And none of the participants tried to spin the object as they dropped it. So basically, to describe our process, a volunteer would stand 1 to 3 floors above the ground level and outstretch their hand above the target, and the 2 other volunteers would be on the ground level, marking where the object landed relative to the center of the target and observing the accuracy and precision for each object. We would repeat this process for each of the volunteers so that we dropped each object 10 times from all 3 floors. And to ensure that we were accurate in describing where the object landed, we used a slow motion camera feature on our phones to check that landing plane. So this is an image that just depicts the process. Our units for height were measured in story levels above the ground, so that was categorical data.
As far as performing the design, this is kind of like on the here you see like a picture of the actual target that was used, but there's a clearer picture coming up. But basically, for the performing part, we used a 3-factor ANOVA test for significance, and then we basically wanted to test for accuracy, and by accuracy we meant by the distance from the center of the target, and then for precision we did the distance from an average point, and by average point we mean like, for example, you'll kind of see whenever we have a clear target, but whenever we are dropping it, if we know that, okay, this is usually where this person's drops fall around, then that's how we're going to test for precision. And then we ended up compiling that raw data in Excel. And then this slide were some experimental videos that we took. So during the while we were performing the experiment, we did use eyesight, but we also used our cameras, and we put them in like slow motion so that we can see exactly where some of the objects landed. And then basically, once we like replayed the videos, we were like, okay, this is precisely where it landed. And then we were able to make a mark as to where the object landed there.
So we'll play the video, but just fair warning, it might be a bit loud, so feel free to turn your volumes down.
So this is basically like the graph that I was saying that it would kind of be easier to visualize. Given that we had 3 participants and we had 3 different levels, and then we also had like 3 different objects, we basically tried to make it to where the color kind of represented, okay, this is like this specific object, this is a specific person. So for me personally, whenever I would drop the ping pong ball, they will mark it in red. Whenever I would drop the quarter, they mark it in green, and then, so on and so forth. So if you like pay attention to like all the red dots, the average of that, the average like point of those would be like whenever we were measuring for precision, and then the distance from each of those from the center is what we meant by measuring for accuracy. And then we basically just made sure to get that with all 3 of the participants.
So 278 trials is quite a lot, but we broke down the results a little bit so it's a little easier to visualize. And you can see here, this is all of the drops for all 3 people are color-coded. And this makes it a little more clear to see how Aditi was a little more precise in being in the northeast region up there. Whereas Darius and David were a little more accurate. They were more centered around the center, but had a little bit of a wider spread. You can go to the next slide. This summarizes just Aditi's drops based on the objects are color-coded, and then the floor is the symbols. And this is kind of not surprising. As the floor increases, they get a little less precise, a little less accurate. And then the objects are there isn't really that much variation we can see between the objects, but we'll get into that into the ANOVA test. You can go into the next slide. And then here's Darius's drops. And again, when we go into the ANOVA test, we're testing we're applying 2 different tests. One is the accuracies, which would just be the distance from all of these to the center, and then one would be precision. So for example, if we're testing the precision of the ping pong balls, we would just take the mean X coordinate of each of these red circles and then the mean Y and create like an average point that way. And then basically apply the accuracy test to that, where the distance from the average point instead of the center point. You can go to the next slide. And then here's David's drop as well. So then the next person we'll talk about here's the floors as well. This isn't surprising, as you can see, as the floor increases, it gets a lot less spread out.
For data analysis, we ran the tests in MATLAB, and they were also verified by hand. What that means is we utilized the code or the equations from the book and the information from the Excel files to calculate each value. Our significance value was 0.05, which gives us, for the p-value. We had 7 unique null hypotheses, and as they're listed there, a key for this is A is the floor, B is the person, C is the object. And our alternate hypothesis were that there was no main effect for each of those interactions or person, floor, object. Next slide. Here we can see the analysis of our ANOVA test for accuracy. We've highlighted the 3 sources that didn't comply or did not work with our p-value was lower than that of our significance. So for this, we rejected the null hypothesis for A, B, and the interaction between B and C. We failed to reject the null hypothesis for C, the interaction of AB, interaction of AC, and the interaction of AB and C. We do not have significant evidence that our significance value levels to suggest that there's a main effect for the object between the floor and person, between the floor and object and between the floor, person, and object. And we have significant evidence that the P value that suggests there is a main effect on accuracy due to the floor, the person, and between the person and object. From here, we have our interaction plots. And from this, we can see that there is no interaction at all between level and person. Depending on the person, nor is there an interaction between level and object, depending on the levels. The trends that can be identified from the interaction plots are many, including an overall decrease in accuracy as the object being thrown or the person throwing the object changes between the floors.
So moving forward, we're now going to look at the main effect plots for the accuracy data. So from these three graphs, we can see that we have both like categorical data and numerical data, so qualitative versus quantitative, and we can make some observations by looking at this on the slide. So looking at the first graph, the mean, which is basically, like we said before, the mean of the distances from the target center versus the levels, it looks as if that as the level increases, the accuracy decreases, and going on from that. The second graph shows us that David seems to be the most accurate as a DT is the least. And then the object graph, the third one, shows us that the quarter seems to be the most accurate projectile being thrown, as opposed to the ping pong ball, which is the least accurate. And now that we looked at the data for accuracy, we'll move on to our findings for our precision data. So we ran an N-way ANOVA test for our precision data on MATLAB and found that the level factor was basically the only one with a low p-value. And according to our original hypotheses, we can only reject the null hypotheses for factor A, which is the levels, and fail to reject for all other sources listed on the slide. And that shows us that we do not have enough significant evidence to show us that there is a main effect for the other sources than level. However, we do have significant evidence at the 0.05 significance level to suggest that there is a main effect for the different floors. And again, we have the interaction plots. This is for the precision data that we have. So on the subgraphs, so row 1, column 2, and 3, we can see that there is no interaction between the level and person, depending on the person, nor is there an interaction between the level and object, depending on the levels. And we can see that this is so because the lines do not cross. However, it does show that the trends can be identified, that there seems to be an overall decrease in precision as the object being thrown or the person throwing the object changes between the floors, which can be seen on the plots column 1, row 2, and 3.
So here we have the main effect plot for the precision. And similar to accuracy, you can see as level increases, precision also decreases. And what was interesting here was Darius was the most precise and David was the least precise. Now, if you remember, David was also the most accurate. So it's very interesting that he would be the least precise. We also see here that the quarter is still the most precise, as it was the most accurate. And now the bottle is the least precise, with the ping pong ball having similar precision as it did to accuracy. So the probability of a type 1 error is 0.05, as our significance level was 0.05, and the probability of a type 2 error is not applicable in this setting, as the tests we were running didn't have a power. And based on the main effect plots and interaction plots, it appears that as floor increases, both accuracy and precision decrease, as well as person accuracy is not related to object precision. And some things that kind of didn't go as smoothly while we were testing was that we didn't have enough objects. The bottles, we only had 6, and we were doing 10 replications. So it took a lot of extra time just going back and forth between the 3 other floors. And yeah, we would definitely use objects more in abundance next time to increase productivity. Another thing is we didn't drop the objects in a vacuum, and drag was present in various objects. And what we would do differently is change the objects proportionally based on the Reynolds number. So as a tester, when I was dropping the bottle, for instance, it's not a round shape. And if it was slightly tilted at the drop, it would go towards that direction. And it was very noticeable from the 4th floor. So some next steps, there seems to be a relation between object accuracy and object precision. We would run more tests to confirm that. There also appears to be a relationship between object weight on object accuracy and precision. However, like I said before with the bottle, we can't really make conclusions based on that due to the drag. And yeah, the inconsistent aerodynamic shape doesn't allow for too many conclusions. So here was a rough timeline that we followed. And here we have, so everybody participated. They did their fair share. We had to overcome a few things with time zones and people being in different locations due to COVID, but everybody was vital to the success of this presentation.